Hello everyone, welcome back to this new video made by the academic officers from EconSoc. Today we are going to talk about confidence intervals, something that is covered in the EC124 module, stats techniques taught by Jeremy Smith. And this concept is probably one of the most difficult things that you're going to cover in this module, alongside the power of test concept, which I will be covering in the next video. So let's get started with this one. So the concept of a confidence interval is basically the reverse of a hypothesis testing. In the hypothesis testing, you're trying to find you find the value, and then you compare it against the critical values that you have, and then you decide whether to reject it or do not reject it, depending on the position of the value against the critical value. In this case, in confidence intervals, we're trying to find the whole range of values that you would accept, that you would not reject in the hypothesis testing. So yeah, we're trying to find this area delimited by these two vertical lines that are the critical values. And there is a very simple formula that you want to remember and take into your exam, and that will help you a lot with these kind of questions. And that is x plus minus critical value times by the standard error. This first term sometimes changes depending on what kind of questions you have. So for example, in match pairs you might have x1 minus x2 or something like that. But yeah, in general this is one thing, and then and you add or subtract the critical value, which is always there, and then you multiply by the standard error. Okay, so now let's start to apply this knowledge in a real question that you might have. This question is from the term 2 handout 6, which is provided by Jeremy Smith on Moodle, and these are the last pages in your handout. He gives you a lot of sample questions with the answers, and I think it's worth practicing these questions prior to exams, or just to get a better grasp of this concept. So yeah, let's start with this question. So it says that a random sample of 125 economics students were asked to rate the importance of a particular job characteristic on a scale from 1 to 5. So this is a very important information. We know that n equals to 125. And then for the question on job security, the sample mean rating was 4.18. Another very important piece of information. So we know that x bar equals to 4.18, and the sample standard deviation is a 0.08. We write it down as SC equals 0.8. And we're asked to find the 99% confidence interval for the population mean. Okay, so now with the equation that I gave you earlier in the previous page, I urge you to stop the video for a few moments and try the question yourself, and then I'll be covering the solution. So let's try and figure out how to solve this question. We are given some information, and we want to plug this information into our formula so that we don't complicate the question too much. And we are trying to solve this question as soon like in the least amount of time as possible. Yeah, so we have x that is equal to 4.18, and then we write plus or minus. The confidence interval is something that we have to find out by ourselves. We know that this sample has 125 observations, so it can be a t distribution or a normal distribution, because when the sample size is large enough, it's basically the same. And from here we can basically look at the table for normal distribution, and we also know that we are asked to find the 99% confidence interval. So we have to find out basically the reverse, so the 1%, and we know that in the case of normal distribution these are two-sided, so we have to find the 0.5 value for the critical value. And if you now go to your statistical tables, you can find that the probability of x being greater than a of the 0.5% is 2.575, and then you multiply this by your standard error, which in this case is not straight this one, because we're also given a number of observations, and we have to do 0.8 over square root of 125. And this we will do the value of 4.364 for the plus case, and 3.996 for the negative case, which means that any x value in this range, you do not reject it. So yes, just some final remarks about this concept of confidence interval. I think the most important thing is to know how to identify the value of x, the value of the critical value, and the standard error.